Look at that! It's me, John Park, right here on your computer. It is John Park's Workshop here on Adafruit Industries. Thank you for joining in today. Guess what? It's the 50th episode of my live stream today. How about that, huh? Crazy. So I want to thank you all for coming out, and let's see, can we get a level check? I'm going to make sure my speakers are off so I don't get any feedback. There we go. I don't know if our good friend C. Grover, aka CG Rover, aka Jan, is hanging out, but he usually gives me a nice level check. I got the AC running, I got the door closed to the workshop, and we're ready to build some neon signage today. Not real neon, it's actually LED neon, but I think you're going to like it. So let's see. It looks like C. Grover is checking in the Discord chat. If you are watching us on YouTube or Facebook or Periscope or Twitch, come join the chat in Discord. That's where most of the chat is happening. Of course, I know some people are on some connections, mobile or otherwise, where they don't have as easy a time using Discord. And we also have people in the chat in YouTube. Those are the two that I'm able to watch. I can't split my brain enough to look at all the possible places. So, okay, good. Our level's pretty good. I'm going to move that up just a little notch. And I'm trying to cut some of my AC noise with rolling off a little of the high end. And good. We've got the low cut filter. We're ready to go. So let's start off with a coupon code. Today, and only today, you can get 10% off in the Adafruit store if you use this code, ARGON, ARGON, A-R-G-O-N. That will get you 10% off on anything in the store that you can put into your cart that'll help you build your next amazing project that hopefully you'll come and share with us, maybe on Wednesday evenings on Show and Tell, or in the chats in Discord or on the forums. We'd love to see your work. And that is good for everything you can buy except for software, except for gift certificates and subscriptions. Those are the three things you can't do. Good. We are completely audible in Austin. Thank you, Jeff Gatlin. Good. Peak at -2 dB. That's as close as I dare get. I'm going to touch it down just a little bit so I don't peak you out. We are not gone. I don't know what that's about. Argon. Oh, I get it now. It's a pun. I had to say it out loud. So Argon. And the reason that's the coupon code for today is not all neon signs are made from neon gas. A lot of them use a mixture of inert gases, argon, and mercury. I think neon is the reds and the pinks, or the reds and the oranges. Anyway, that's all Wikipedia told me. And let's see. Now we can move on to our product of the week. And the product of the week today, it's actually something we'll be using in our project, and that is the Adafruit Metro M0 Express. The Adafruit Metro M0 Express is a fantastic microcontroller board. It is the same footprint and pin spacing as the Arduino Uno, and it is Arduino compatible. It also runs CircuitPython, which is awesome, which I love. And check this out, now you can also run it using Makecode. What? Makecode, you ask? Yes. So there is a site, I don't know if it's beta still or not, but there's a site. If you go to maker.makecode.com, you will see that there are choices in the Makecode world beyond the Microbit and the Circuit Playground Express, which are the two main ones that I'm used to seeing over in regular Makecode. I think maybe Lego is on that one now, and I know there's one or two other boards. But now at this maker.makecode, you'll see pretty much all of the Express boards are now available, as well as some others. So the Trinket M0 Express, no, that's not an Express board. The Itsy Bitsy M0 Express, the Feather M0 Express, and the Metro M0 Express, those three for sure, I know you can program right there from Makecode. Maybe the Gemma and the Trinket. Gosh, now I'm thinking maybe you can, yeah. So go check it out. We'll look at it a little later. But anyway, Metro is a fantastic board, Metro M0 Express. It is at product ID 3505, and it looks like a Metro card from the Metro system in New York. It's kind of like a little subway map. on the back. I bet that's Phil B. That has a Phil B sort of feel to it. So excellent board, and it's got, what can I say about it? It's an ATSAM D21 chip on it. It has micro USB, which is nice, rather than the large USB-A size that you'll find on an Arduino Uno. It's got a little on-off switch on it, which is great. I've also heard some people complain in the forums where they think they've gotten one dead on arrival, and I think it's after they've plugged it into DC and it's not turning on and off, and that's because it's got an on-off switch, which we're not used to on a regular Arduino. So we'll be using one in the project later today. So that's the product of the week. I love them. They're great. You should have one. Okay, well, you know what that does? That brings us to our Makecode Minute. Yes, that's right, the Makecode Minute. And it's time, of course, for me to bring up my large green screen Circuit Playground Express. Sorry, I can't focus it better today because I was having some camera software driver issues. I was using some third-party software to tune the focus and some other things, and that was screwing my other cameras. So, for today's Makecode Minute, what we're going to look at is switches. So there is a switch built onto the Circuit Playground Express right here. And if I take a look at my Makecode that I've set up, I'm using this on-switch move left block and the on-switch moved right block. And what that does is it registered, as you might guess, which direction you flipped the switch to. So what I've got going on in this software right now is when I switch left, I'm doing two things. I'm setting a variable that I made called song choice to 0 when I go left or to 1 when I go right. And this is a great way to use switches in order to change a variable between two states, which then you'll use that variable later. So we'll notice when the program starts, I have set song choice to 0, and I have the pixels at yellow. Now, depending on the direction of the switch, if I'm in left mode, the song choice is equal to 0, and that means I'm going to play the power up until done, and you'll notice I've changed the color of the neopixels when I go left. When I go right, I switch the neopixels over to this side, and now the same button A is going to play a different song. So I'm going to actually set my mic next to this. Sorry for the noises here, and let's do it. So there we go. I've switched to the right, switched to the left. When I press the button when I'm in left mode, go right, same button, left, right. And that is how you use a switch on the Circuit Playground Express inside of Makecode in order to change a variable. All right. Let's see, now what, ooh, that was a bit of a preview there. We got tools and techniques coming up. Or tools and tips, what am I calling it? Tools and techniques. So, first I want to check in with the chat. We have any questions on that? I don't know, that felt fast, but I'm trying to keep my Makecode minutes under 2 minutes. You know, so twice as big as what the name would imply. Which one is on and which one is off? Yeah, exactly. The people, okay, there's a lot of funny people over in the Discord chat. You're missing out on puns and much humor if you're not hanging out over there. So let me take this off the screen here. So for tools and techniques, what I want to talk about is switching high voltage, high current peripherals using the microcontrollers. So we're going to use our Metro M0, which generally speaking on the Metro M0 Express you're going to get about a 3.3 volt output over the pins. When you switch a pin to high and you're trying to light up an LED, that works out pretty well. But we want to do things like light up these neon LED strips, or you want to throw a solenoid or turn on a pump, turn a motor, even unipolar or unidirectional stepper motors. You need to send a heck of a lot more voltage and current through, or higher voltage and more current through. And a great way to do that is with this little guy here, which is a Darlington transistor driver. So A Darlington transistor is a pairing of transistors that's used essentially to amplify the voltage available. And in some ways you can think of it almost like a relay. We can send a low control voltage to one leg, and that will allow a higher voltage to pass through the others with a common ground. So what the ULN2803 does is it gives us 8 of those. So you'll notice there are 9 of these rows, so there's 18 pins. 2 of them are used to connect to the power and ground, and that's the power that you're wanting to flow through to the device. And then the other sets, the other pairs, are used to turn on and off those individual arrays of the Darlington transistors. So I have a demo that I want to show you over on the desktop. So let's switch on over here. I can hide that. So there I have one on the workbench, and I'm going to head over there now. There we go. Ooh, I have those. I'm going to have some confusing camera switching today, because after I fixed some of my camera problems, they came back in a funny order. So I'm a little nervous about my switcher box. So I'm going to take this out just a little bit here. Something like that. Let me refocus. And I want to get something to point with that you can see. I like using a piece of, oh, here we go. There's a blue zip tie. Can you see that? Yeah. So here you can see I've got, on this breadboard, down here we've got the ground pin, and here we have power. So this little micro grabber I have right now, this is running to my benchtop power supply, and I have that set for 12 volts on that channel. So this is going to allow 12 volts to flow through any of these array pairs when they're triggered. If you look up here, we've got, I'm just going to disconnect this one for a second. We've got this blue grabber here. That is connected to a 3-volt source, and they share a common ground. So right now that's actually also, that's another channel on my benchtop power supply. So what's going to happen is when I turn on the 3-volt, it's going to allow the 12-volt to flow through. And so any device that I want to trigger, I'm going to place into this matched pair here, the ground pin, and I'm going to place the power pin of that solenoid, in this case, into the same power, the same 12 volts. So let me zoom out just a little bit more here. That'll work, and I'm going to focus again. So here you can see I have this big beefy solenoid, and there's no chance that you're ever going to be able to power that from the microcontroller itself. It's just going to give up. So, excuse me one second while I bring up the chat on my, here we go, and is volume down? I think it is. Yeah, there we go. Okay. So what I'm going to do right now is, you can see me on the side, yeah, so I'm going to trigger the 3 volts, 3.3 volts on my channel 3 of my power supply. And all that's doing is sending that little 3 volts to this transistor here and then through the common ground. So that then allows the full 12 volts to run through this guy. Now, here's an even cooler demo. What I'm going to do is trigger that same thing from a coin cell battery. So this is just a typical 3.3 volt. Are these a 3 volt? 3 volt. 3 volt, I like these IKEA batteries. 3 volt battery. I've got ground plugged into the common ground rail on my breadboard. And this happens to have an on-off switch. I'm going to turn this to on, so that's just on. And now all I'm going to do is touch this pin here. So you can see, just with this little 3 volt battery, it doesn't take much current and it doesn't take much voltage to trigger and open up the valve that allows this nice big, I think this thing is drawing about a half an amp. Yeah, a little more than half an amp. So there's no way you could trigger that thing off of 3 volts and a little battery. But look, our little Darlington array allows it. Now, what I'm going to do now is show you, check this out. I've got one of our neon strips. And so if I turn my coin cell on and off, you can see I can turn that strip on and off. And that's using this sort of fourth pair down here on the transistor array on the Darlington driver. And then when I want to, I can trigger the solenoid, and these are independent of each other. So it's a really nice little package. It costs like $2, yeah, $1.95. And it gives you the power to drive up to 8 different devices that need some higher voltage and current flowing through them. And so I imagine that you can guess now why we're going to use that today for neon strips, right? Okay, check this out. I'm going to attempt to switch cameras. Is it switching at all? Let me see if I'm clicked into my software. And ooh, none of those are working. Okay, I'm going to unplug and replug my switcher box to see if I can convince it to do its job. If you don't remember that episode, here we are in episode 50, unbelievable, but back in one of the earlier episodes, I built a button box that uses, I think I have a feather in there. I think it might, whoops, I think it might be a Feather M0 that controls, there we go, that controls my camera. And it just does so by sending USB key commands to Wirecast, which is my broadcasting software. So let's see. I guess these are all, yeah, these are all actually in the order I thought they would be. Good. Here's a cool view of this, right? Because these signs look, these neon look amazing. Look at that. So here's my solenoid, and here's my little coin cell running that. Right on, huh? I'm gonna leave that on. It's a nice light source. I haven't tried using these for photography yet, but man, they're really nice big diffuse source that you could, you know, coil up and get a nice big disk of light. Will I be putting the parts list in the description? Asks Magicar Pet Moto. Parts will be in the guide, so I'm going to create a Learn guide. I've actually started creating it already, and it'll be published tomorrow evening by 5 o'clock Eastern Standard Time is the schedule. And that will, yes, tell you all the parts you need, which we're going to go over, actually. I think that's a good segue. So let's do it. I think I'm going to stick with this view, and I may, you know what, I'm sad to say it, but I'm going to turn off this light because you won't be able to see the other stuff as well. So let's bring this guy into play here. And so the first thing I want to talk about is these neon strips. So let's see. I have started taking them apart a bit. So you just saw that one that I had lit up there. Let's give you a nice view here. Okay. No, that's not the one. The close one, there we go. Boy, that one's got a nice color balance on it. I need to fix my color balance now after screwing with cameras. So these neon strips, this one I've actually cut. They are 1 meter long. Here's a really nice one I haven't opened yet. This is a neon green. Can't wait to use that. So that's what the 1 meter long strip looks like. And they are a simple, these are not NeoPixels, first of all. I know a lot of people ask about, can you control these from software? The only control you can do is on and off. So they are a simple 12 volts to run these. So you can do it 9 volts to 12 volts will work. So I've got, here is a, you'll notice I labeled this one. This is 12 volts. So let's plug that in. And I don't want to unplug that. I have a lot of power strips here, but I still managed to run out. It'd be good to do a little maintenance and run through and unplug things that maybe don't need to be plugged. So what you can do if you just want to power these is get one of these nice little barrel, female 2.1 millimeter barrel jack breakout plugs, and you can simply screw the black and red wires that come from the neon strips. So I'm going to run red into plus. This has a little plus sign on it for positive. These are center positive, which is important to keep in mind in case you do anything in the guitar pedal world, because guitar pedals are this weird industry where center is negative. So don't mix and match, because most stuff we deal with is center positive. Okay, so now if we plug that in, so there's a 12 volt, that's the cool white one. Man, that thing is bright. Now, this being a very simple animal and not a NeoPixel, you can simply cut anywhere you want and solder in a red and a black wire. You want to pay attention to which side is ground and which side is power. And then you can run these. I'm just going to do a dangerous thing here and just kind of plug it into the terminal. Right? So either end, it doesn't matter so long as you get the polarity correct. Which also means you can daisy chain these things. So here I've got a little nub of a blue one. And what I'm going to do is use one of our lovely little connectors here carefully and just get the polarity correct. That's all you got to do here. And now when I supply the 12 volts, we get the blue and the white. And you can tell that it's often easier on camera for you to see the reflection, the reflected or bounced light to judge color because it blows out a bit. So this is pretty cool. This means that you can create really interesting color patterns. All it takes is cutting these apart and splicing them. So on the topic of cutting apart and splicing, let's get another sacrificial piece here. I'm going to zoom down a bit closer. Sorry for the camera shake. And what you'll see is we're going to take one apart here so you can really get inside of it. And I'm just going to use some small scissors, which the only ones I have around here that seem to be tiny are the ones on my little Swiss Army knife. So these have a silicone rounded side, and that's the sort of neon side that we see on the top here. And then there's a second material. I don't know what it is. It might be a white silicone for all I know, but it is actually silicone for all I know. But it is actually two separate materials that are molded together that provide light blocking on this side, because this is actually where the LEDs are facing. And not as much light blocking on here, but they conveniently put this stripe so you could see every 3 centimeters, I believe it is, there's a mark, this black mark that tells you you can cut it here. So let's first just open one up. So I'm going to cut this open, and you are not going to be surprised by what you see inside. It's a very familiar type of light strip. All right, so if you've ever gotten like under cabinet lights, again at IKEA, sort of normal, non-color changing ones, that's what you'll see. It's just really a fantastic strip that they've created, this silicone, which is dyed. The LEDs, I believe, are no, they've got to be colored. Yeah, I think these are colored LEDs as well as the colored, let's find out. Let's try one over here. Yeah, let's light this guy back up. It might be blinding, but okay, yeah, that's definitely a blue LED. It's not just the color there. So now if you want to, you can see if you cut on that mark, and you can do it while the silicone is still on there, then you can peel back and solder onto it. So what you're soldering onto are these little pads here. And so if you cut it pretty much right down, dead down the middle, it's not big, but it'll take solder. So I've soldered onto these and then just wrapped them in a little bit of electrical tape in order to give it some more strain relief. But that is how we're able to sort of daisy chain these together, and I'm just using these nice connectors like you saw in order to do that. So, gosh, we are running low on time, so let's get out the main event here, which is this sign. I'm going to light it up for you first, and then we'll take a look at the board that you're going to be able to then create from the Learn Guide. So here is Adabot, and here are some little patterns. What you're going to see in the final is I'm going to mount these vertically. Actually, let's go ahead and do that now. Like one big sign. Let's see if I can get it to just rest here. This might be asking a lot. As tools go falling. There, okay. So let me turn down the shutter, actually turn up the shutter speed and zoom in on that. There we go. See a little better. And now what I'm going to do is head over here and turn on, I'm going to mess around with the buttons I've got on here. So I've got one button that just simply turns them all off. And then that's a sort of latching switch, so that'll turn that on and off. And then I've got another button that will set the bottom emblem into blink mode. And that'll turn it all back off, back on, and out of blink mode. So they're both lit up. Now you can imagine that actually all I'm using right here are 3 of the Darlington transistors in that driver. That driver, by the way, is the same driver that's on our Cricket board. If you're familiar with the Cricket, it has some drivers for electromagnets and solenoids, and that's what we're using in there. So let's get that a little brighter. Sure, that's good. So let's take a closer look at what's on that board. And just bear with me because I'm going to unplug that from power and drag both parts here. And I'm also going to show you behind the scenes on the back of this. What you see may shock you. I mean, not shock you, but so let's see. I think this one's a better one to look at. So what you can see here is I've got wire harnesses using our little connectors, and I've got zip ties connecting these tubes to the board. So what I did was just traced out in pencil the pattern that I wanted of Adabot's head and the lightning bolts, and then laid them out and used a small screwdriver to puncture holes, and then clear zip ties which don't show up when it's lit. So I'm going to set these over here, and we're just going to take a look at how that's put together. So let's go to this view for a second. What is that? Oh, that's this. I thought that was a big shadow. So you'll see what I have here is one of our little 4-pin connector cables. So I'm going to unplug that. And that's all that's connecting it to the sign. So I made this very modular. And now I can switch to this little camera view here and take a closer look. So I've got the Metro M0 with a permaproto screw shield on top with our circuit. I have a 4-pin cable that comes out, and that gives us the power and the 3 grounds that actually turn on and off those lights through the Darlington array. And then I've got these 2 buttons that I showed you. So this one is the one that clicks. Let's see, can I power? Yeah, I can power that from this. So when I turn these on, I've got both buttons lighting up to tell me that it's on or off. And then when I set the blinky mode, that button blinks there. So using these nice little illuminated buttons that we have. And if you take a look even closer here, just focus in, you can see there's my Darlington ULN2803. I'll turn it the way we've been looking at it so it looks a little more familiar. And so you can see what I'm doing is I've got 3 pins from Arduino, 12, 11, and 10, going to the first, second, and third Darlington pair. And then their outputs are going to these screw terminals on the proto screw shield so that I can then plug in this guy here off to my sign. And so that, I think, is a pretty neat package. And what I'm going to do with the final is just mount this to the back side of the board. I'll actually use that nice zip tie rivet trick to go through some of the mounting holes that are built onto these boards. And that will give us, I think, a pretty nice, neat package for creating a sign. So let's head back on over here and wrap things up. Hey, look, it's me. So that is the thrust of the project. Let me know in the chat if anyone has any questions. But I think these neon tubes, these LED tubes, are pretty excellent for all kinds of costume effects, installations, lighting in general. But I also think back to when I used to build sets and props in the theater, that these would be amazing for doing neon signs, because you just can't make a custom glass neon sign on quick demand. So unless it's a big production, you won't have that budget, or you might not have the facilities or the skills. I've never made a neon sign. I'd love to learn. But these give a really impressive look. They look an awful lot like neon. So I think that people are really going to be excited about using these. Despite the fact that they're not programmable in the NeoPixel sense, you've seen here today using a microcontroller and our transistor array, the Darlington driver, you can animate things on and off, and even do effects if you want to. You could do some flicker. I haven't tried PWMing them through this, but I have tried doing some little flickers, and they look great. They look just like neon. So, yeah, John, are they PWM responsive? I don't know. Does anyone know? I'm not sure. Does anyone in the chat talked about this? Everyone's been asking, do they respond well to PWM control? We'll find out, okay? I will definitely test that. So before we go, I want to remind you once again that you can get All right, now we're back. My alarm went off, and Mr. Certainly told me. Thank you so much. There it goes again. You hear it? That's my red blinky light alarm over there. So thank you, everyone, for telling me. Did it? Yeah, huh. I clicked on one of my windows on this new configuration, and it sucked the audio away. Sorry about that. But probably what you missed is you can use this coupon code today to get 10% off in the Adafruit store on anything you want to get other than software, gift certificates, and subscriptions. So thank you again for tuning in on this, the 50th episode of John Park's Workshop for Adafruit Industries. I'm John Park, and look for the guide coming soon. It'll be out tomorrow, 5 o'clock Eastern Time. So I'll be hanging out over in the Discord chat if you guys want to continue the conversation, and I promise I'll try PWMing these to see if we can fade them on and off. I just don't know. It'll be cool to find out. Thank you so much, everybody.